In this problem, we are given that a farmer has a trapezoidal field along a river with 1,200 feet of fencing. And we are also given that one of the parallel side is 3 times longer than the other. So in this situation, we have to calculate the largest area. So this is basically one of the application type of problems involving maxima and minimum. It's an application type of problems involving maximum and minimum. So we will be following the strategies which I have outlined here to solve these type of problems. So initially we have to draw a picture, and once we have drawn the picture, we have to identify the objective function. So this is basically a quantity which has to be maximized or minimized, and then we have to write a formula for that. So in the third step, we have to find the constraints, or using the given constraints, we can rewrite the objective function in terms of only one variable. And finally, we will use calculus to maximize or minimize the objective function. So let's start to do the each steps one by one. Let's focus on the first step, which is drawing a picture using the given information. So here I have drawn the picture of the field of the farmer, which is basically a trapezoidal shape. This red line, this is basically along the river. And since one parallel side is 3 times longer than the other, I can mark this as x. This is one parallel side. If that is the case, the side which is parallel to this is this side. So the length of this parallel side is going to be 3x, because this is 3 times longer than the other parallel side. So we have created some variables for the sides, and remaining is we have to let this length, that is basically this is the height of the trapezoid. We will assume this to be y. Maybe I can call this as A, B, C, and D, where AB and AB and CD are parallel sides. These are parallel sides, and BC is basically the height of the trapezoid. So this means we have successfully completed the step 1. Now let's move on to the step 2. In step 2, we have to identify the objective function, or basically the quantity, which is basically the objective function. So if you look at the problem statement, we have 1,200 feet of fencing. So let's write a formula for the fencing. Oh, I'm sorry, that's actually not the objective function. It's clearly given in the question. We have to find the largest area. So basically we have to maximize the area, which means that is our objective function. So this is basically our objective function. So I can write down the objective function as maximizing the area. All right. So let's write a formula to maximize this area of this trapezoid. We know that the area of the trapezoid is given by half height times sum of the parallel sides. Sum of parallel sides. Let's identify this information from the picture. We know that the height is BC, which we have kept it as y. So therefore, I can substitute height as y here. This is 1 by 2 times of y. Sum of the parallel sides, this is 3x plus x. So I can put this as 3x plus x, and which is basically 4x. I'm going to write 4x straight away. Now this is the objective function we have written. So we have completed the step 2. Now let's move on to the step 3. In step 3, we have to identify the constraints. So if you look at the problems, we have this 1,200 feet of fencing. So we can utilize this information to create the constraint. So let's write the constraint. Let's call this equation as equation number 1. So we are now going to write down the constraint. We know that the fencing is basically the perimeter of the trapezoid. So in our problem, we are not including the this side, which is along the river. So basically, we have to include only the three sides, that is AB, BC, and CD. So to find the perimeter, we have to sum up all the three sides, which is 3x plus y plus x, and this is given as 1200. So when you add these three sides, we'll get 3x plus x is 4x plus y. 4x plus y equals 1200. This basically is our constraint function. So you can write down here 4x plus y equals 1200. Now let's use this construction and we solve for y from this one. So we get 1200 minus 4x. Let this be equation 2. Now since we have to find the largest area, this is our objective function. So we have to focus on this one. So let's utilize this and create this as a one variable function. So I'm going to write down a. This is equal to 1 by 2 y. We know that y is equal to 1200 minus 4x. So I'm going to replace y as 1200 minus 4x times of 4x. I already have a 4x in this equation. So this is our objective function, which we have successfully created in just one variable, which means we have completed the step 3 as well. So let's call this as area function as a of x equals, I can simplify this. This 2 and this 4 will get cancelled as 2 times. So which means I have 1200 minus of 4x times of 2x. Let me distribute this 2x. So when I do that, I'll be getting this area function equals 1200 times of 2x is 2400 x minus 4x times of 2x is 8x squared. So this is basically our objective function after we have simplified the variables. Now let's focus on the final step, which is we have to replace the calculus to maximize or minimize the area. In this case, we just have to find the largest area. So we are focusing on maximizing the largest area. So the fourth step, we have to set up a prime of x equal to 0 so that we can find the critical numbers. This is equal to 0 to find the critical numbers. So let me first find a prime of x. This is basically the derivative of the area function. So you're focusing on this area function. So if I have to derivative of this function, I have to differentiate the right side as well. Differentiation of 2400x is 2400. Differentiation of x is 1. Minus of 8x squared differentiation is 8 times of 2x, which is basically 8 times of 2x. This is basically 16x. So I can write this as 16x. So now we have to set up this equal to 0 and find the critical number, that is the x. So when you put this equal to 0, this implies 2400 minus 16x equal to 0. This implies we can solve for x from this one. 16x equal to 2400. So therefore x equal to 2400 by 16, and this is equal to 150. We then use the second derivative to identify whether this point gives us the maximum or minimum area. So let me find the second derivative. So first let me copy the first derivative of the area function, which is 2400 minus 16x. Now I have to find the second derivative by differentiating both sides. So I'll be getting 2400 is a constant, so that will become 0, and this is negative 16. Now we have to substitute x, that is the critical number. This is basically the critical number. So we have to substitute this critical number into the second derivative and test whether it gives a maximum or minimum value. So since it is independent of x and this is negative, which is always negative, which means this is less than 0. So this is a point of maximum. And this confirms that the area is maximum. That is at this point, the area is maximum at the point x equal to 150. So now we know that the area is maximum at x equal to 150. We can go back and substitute into the area function, that is into this function. So let me do it here. So therefore this a of x, that is a of 150 equals 2400 times of 150 minus 8 times of 150 square. So when we simplify this, this will be 180,000. So this is the largest area. We can write down this in the final step. That is the largest area equals 180,000 feet square. Since the unit of area is unit square, we have to put the appropriate unit as well. So we have found the largest area using the calculus method.